Hi everyone. In this video, we will work on number 45 from section 5.3. The involved integrand will be an improper rational functions because the degree of the numerator equals 4, degree of the denominator equal to 2. So the top larger than the bottom. The idea is to do a decomposition or write this as the sum of a polynomial term plus a proper rational functions. We believe that in general, a proper rational is easier to deal with. Okay, this is the step 0, where we analyze the problems and figure out a plan to solve it. The next step is to utilize the polynomial long division to figure out this decomposition. Okay, this technique is actually a generalization from the long division for numbers. All right, so I will just show you the process. Be very careful about our writing style here. For you, possibly you could, in practice, you could write plus 0x squared plus 9x. So it will remind us that there is actually a term in terms of x squared. But no matter what, as long as you can get the correct remainder, then I don't think that will be an issue. All right, so go through this procedure. There will be some details there, and also pay attention to the sign, right? Positive or negative. All right, then as long as we figure out the degree of the remainder is less than the degree of the polynomial that need to be divided, then we can stop this procedure. All right, now eventually the polynomial term will be the quotient we have in this long division process, and also plus the remainder divided by the x squared minus 4x plus 1. Okay, this is the next step. Continued, we know it's best we need to deal with a proper rational functions. Intuitively, we may expect to apply factoring, partial fractions, or even the completing the square technique. However, a closer look on these special structures, we could actually utilize the U substitution, choose U to be the denominator, taking the derivative, then we can build a connection between the top and the bottom. All right, so this simple U substitution will help us to figure out the antiderivative of this directly. All right, notice that we don't need to do any algebra technique in step 2, but for the other exercise, possibly we needed to use partial fractions or completing the squares. All right, now once we finish this step, the last step is to combine all the result and figure out the antiderivative of the polynomial term, but this is straightforward. All right, so I will skip the details and only leave the final answer like this one. All right, a quick recap. Step 0, analyze the problem, figure out a plan to solve it. And then step 1, polynomial long division. Step 2, to deal with proper rational function. We could use any techniques we learned so far, not only the algebra technique. Okay, now step 3 is just to combine the existing result. Okay, and I will suggest you to pause the video to check the details of this particular exercise. Okay, I will stop here. Thanks for watching.